this is what we are doing on December 12th, Thursday. This is the second lesson of Unit 2. Take a second and try bell ringer number 2 on your warm-up sheet, which looks a little bit like this. So the thing that you're going to want to change here actually is this is supposed to be a 20. So if you stared at this for a long time and couldn't quite get it, go back and try it again, and come back when you've tried it again to check your answers. Sorry about that. Okay, so it's pretty easy to see that there are 4 stars and they add up to 20. So that means that each star must be 4 stars equals 20, which when divided by 4, we find out that star is 5. So every star is 5, which means that we can kind of just knock those off. So that takes out that entire row. Now if we take off, there's 2 stars in this column. So that's going to change this number to 10. Sorry if I'm a little stuffed up today. There's 2 stars in this column, so this one's going to become 7. This one's also going to become 10, just 1 star. And this one also has 2, so that's also 10. Okay. Excuse me. And then going this way, we're taking off 5, so that is now 14. This one is now 12. And this one is now 11. So if we look here, we've got a triangle and 2 circles make 10, and a triangle and a circle make 7. So we can set up triangle plus 2 circles is equal to a triangle plus a circle plus 3, because 7 plus 3 is 10. So if we subtract the triangle from both sides, that'll eliminate our triangle. And then we have 2 circles equals a circle plus 3. So we take away a circle from each side, minus circle, and we're left with circle, it's a terrible circle, is 3. Circle is 3. So if the circle is 3, well, that's going to change this to 4. 2 3s, 6 minus 10 is 10 minus 6 is 4. 7 minus 3 is 4. Minus 3 over here is going to give us 8. Minus 6 over here is going to give us 6. So we can pretty easily see that when there's only a triangle left, we got 4. When there's 2 triangles left, there's 8. So we know that the triangle is 4. So triangle is 4. So that knocks out that one, knocks out this one. And then up here, we subtract 8 from 14 and we get 6. So now we see that in every column, and 10 minus 4 is 6. So now we can see that where there is only a, in here, 6. Where there's only a pentagon left, there's 6 left in the column. So we know that the pentagon is 6. And that's how we do that one. And that's taken up half of our first video, just going over that. But hopefully it's fun. This is a little brain teaser. Okay. So our objective today is to define and apply the equation to find the slope of a line. We're also going to be comparing the slopes of lines to determine whether they are parallel or perpendicular. So in your notes packet, find 2-2. That's work packet. And up at the top it says slope of a line, and it's got this written out for you. The slope m is the slope is represented by the letter m of a line. So if you see m in regards to a line, we're talking about the slope. Containing 2 points with the coordinates x1, y1, and x2, y2 is given by the formula y2 minus y1 over x2 minus x1. So you don't have to write down all of this, but you need to write down this part right here. This part right here is what needs to go m equals on at the top of your notes. This is the formula that will help you find slope, and you might find it a little bit familiar because it is rise over run. The difference between y's over the difference between x's. Difference between y's over the difference between x's. So make sure you've got that written down. Then look at the slope chart and just make a couple little notes here. If the line is moving upward from left to right, then that is a positive number. We know if we see this kind of line, we know that the slope that we should get from this formula should be a positive number. And if we don't get a positive number for this line, then we've done something wrong in our arithmetic. This is just a way to check ourselves. If the line is going downward from left to right, that slope is negative. If it's flat, that means that y is constant. The x is changing. You know, here's x equals negative whatever, x equals 0, x is positive now. X keeps changing, but y is the same. So for a line where y is the same, it's a horizontal line, then the difference between the y's is going to be 0. And that means that the slope is going to be 0. So if it's flat, if it's horizontal, then it has a slope of 0. A line that's straight up is where y isn't changing. Y is always, y is changing, but x isn't. So this one, x is changing, but y isn't. Now y is changing. We're going from negative to 0 to positive, but x stays the same. So what that looks like when we plug it into our slope formula is x1 and x2 are the same, which is going to give us whatever the change in y is over 0. And whenever we try to divide by 0, we can't. We can't divide by 0, so the slope of a vertical line is undefined. So positive, negative, 0, and undefined. So let's look at a couple of examples. Here we've got 2 points, j at 0, 0, and k at -2, 8. We're going to plug those into our formula. This is our formula, y2 minus y1 over x2 minus x1. There's our y2, there's our y1, there's our x2, there's our x1, and that gives us 8 over -2, because we're subtracting 0. And when we solve 8 divided by -2, we find out that m, our slope, is -4. So the answer to the first problem is -4. Make sure you show your work. For the next line, that's actually supposed to be -2, -3, 3, -5. So we plug those into our formula. Oop, I lost the plot. Okay, there's our formula. And we're going to plug in our numbers. That's supposed to be -2, which means that we're actually going to get -5 minus -3 actually ends up being, remember, minus a negative and plus a positive, so that's -2. And then 3 plus +2 is going to be, or +3 minus -2 ends up being plus a positive, so we've got 5. So our answer here is